All right, picture this. We're taking a journey through deep space, moving backward in time toward the absolute dawn of the universe. For decades, we thought we knew exactly what we'd find, right? A dark, slow, gradual coalescing of gas that eventually, over billions of years, formed the very first stars. But recently, we peered into that ancient cosmic darkness, and what stared back at us has completely upended our understanding of the physical laws governing the cosmos. In this explainer, we're diving into a cosmic mystery that is quite literally rewriting the textbooks. The James Webb Space Telescope just broke the Big Bang timeline. Seriously, it found massive, fully formed galaxies that literally shouldn't exist. We're talking about colossal structures sitting out there in the deep vacuum, shining with the light of billions of stars, at a time when the universe was barely out of its infancy. According to everything we thought we knew about cosmology, these early mature galaxies are an absolute impossibility. You can see the stark, undeniable contrast between our theoretical models and actual reality right here. On one side, we have the standard model's prediction, which is a process called hierarchical merging. This theory assumes a really slow, gradual mass assembly process. Small clumps of matter crash together, slowly building bigger clumps, a process requiring billions of years to finally form a mature galaxy. But on the flip side, we have the JWST reality. In the actual telescope data, we're observing massive, fully assembled, mature disk galaxies, like the system known as JDSGS Z14-0, at a redshift greater than 14. In cosmological terms, that is astonishingly early. The standard hierarchical merging process simply moves way too slowly to account for this.
Section 1. The Closed Box Problem. Cosmic Thermodynamics.
Okay, so standard cosmology operates under this really strict assumption that the universe is essentially a closed thermodynamic box. And according to the Second Law of Thermodynamics, any closed box is irreversibly decaying into a state of maximum entropy. It's basically a one-way ticket to a totally randomized, dissipated state that physicists call the heat death. In this dying, closed-box universe, there simply wasn't enough time or available organized energy for that slow, hierarchical merging process to build these massive galactic structures so early after the Big Bang. Because of this closed-box assumption, standard cosmology hits a massive mathematical brick wall. It encounters what researchers are calling a timeline paradox. As standard models try to calculate mass assembly over time, they create a literal high-mass forbidden zone. It's a threshold that early galaxies absolutely shouldn't be able to cross within the available cosmic time. Yet, there they are. The James Webb data shows galaxies sitting comfortably right inside that mathematically impossible zone. The tension here is immense. But here is the drop. Those galaxies aren't impossible. Our understanding of thermodynamics was just incomplete. Section 2. The ITSM paradigm shift. Zero free parameters. We're looking at a radical new framework called the Integrated Toroidal-Syntropic Model, or ITSM for short. Now, this model doesn't try to just patch the timeline paradox by inventing unobservable dark matter particles. Instead of a closed, dying box, the ITSM redefines the universe as an open thermodynamic circuit. And the engine driving this circuit? It's a concept called syntropy. Think of syntropy as the deterministic counterpart to entropy. It means the universe is continuously taking in ordered information to balance out the localized dissipation of energy. When you redefine the universe as an open circuit driven by this syntropic flow, the timeline paradox immediately resolves itself. Why? Because the universe now has an active thermodynamic mechanism to build complex structures. What's wild about the ITSM is that it models the universe using strictly zero free physical parameters. Unlike standard models that have to constantly tune the amount of invisible dark matter just to make the math work, the ITSM relies on just 3 invariant variables. First, baryonic mass, that's the actual observable matter in the universe, which acts as the stir in the cosmic fluid. Second, the Hubble flow, or the cosmic expansion rate, acting as the thermodynamic throughput. And third, toroidal geometry, the proposed topological shape of the vacuum itself, acting as the structural coefficient of 2 pi. Using just these 3 elements, the math naturally, perfectly aligns with what we actually observe. Section 3. Vacuum vortex cores. Superfluid plenum. Now, in standard models, supermassive black holes are thought to grow incredibly slowly from the collapsing cores of dead stars. But the ITSM suggests that the fundamental vacuum of space itself acts as a macroscopic rotating fluid, a superfluid condensate. In this fluid universe, early supermassive black holes didn't grow from dead stars at all. Actually, they were inherent vacuum vortex cores. Think of them almost like structural defects or whirlpools inherent to the spin of the toroidal space itself. They acted like a massive, hyperdense topological scaffolding that violently and rapidly pulled in surrounding matter from the very beginning. Let's actually trace how this plays out on the cosmic timeline to see the difference clearly. At 0 million years, we have the Big Bang. Now, if we rely on standard merging, by 100 million years, we hit a wall. We enter that high-mass forbidden zone we talked about. But in the ITSM, by 200 million years, that pre-existing toroidal scaffolding, those vacuum vortex cores, are already rapidly pulling in surrounding baryonic gas in a continuous fluid motion. It's literally a thermodynamic shortcut. And because of that syntropic flow, by just 290 million years, the galaxy JWST C14-0 reaches full dynamic maturity. It didn't have to build itself up piece by tiny piece. The fluid mechanics of the universe essentially nucleated it into existence. Take a look at this power spectrum of the cosmic microwave background, the oldest light in the universe. The gray line is the standard model, which is heavily reliant on dark matter. The blue line is the ITSM. When the ITSM models the universe as an open thermodynamic circuit, the syntropic source fluid actually pulls the first acoustic peak perfectly to multipole moment L equals 222. It beautifully, elegantly matches the actual Planck satellite data points without needing a single particle of dark matter. It fully reconciles our local expansion rate with the geometry of the early universe.
Section 4. Thermodynamics Reimagined. Dynamic Equilibrium.
So, if this ITSM framework holds true, it means the fundamental equation of our existence has been missing a massive variable. The total entropy of our universe isn't just some runaway train to nowhere. It is actively balanced by syntropic structural assembly. This completely replaces the bleak, standard heat-death narrative with a dynamic, self-organizing equilibrium. The universe is not a dying closed box. It's a brilliant, ongoing, open thermodynamic engine that actively builds complexity and structure over time.
Which brings us to the ultimate question. If the universe isn't dying of heat death, but is instead an open circuit organizing itself from the very beginning, what other impossible structures are waiting to be found out there in the deep vacuum?